Good morning, everyone. People are still filtering in, so I want to welcome you to the music of the 16th century. Relax. This is a great course. Have a good time. So the musical preludes for every class are intended to sort of relax you and put you in the right frame of mind. I want you to be happy. I want you to learn well. So today, I guess I still have a few seconds. It's like being in the train station waiting for the sweep second hand to come around. So today we are going to talk about mental models. And I know this seems like a lot of mental models because we've talked about it for a couple of classes now, but this is the last class on mental models per se, even though we will come back to this topic multiple times over the course of the class. Also, we'll remind you I have a slightly ragged voice today, so bear with me. Anyway, okay, enough of the 16th century. Welcome to today. So today's AI news of the day, like I said, we're going to have one of these every time, is on brain-computer interfaces. Now, we're actually not going to talk about brain-computer interfaces much in this class. There are other classes you could take for that. Mostly, the state of BCI, as it's known, brain-computer interfaces, is you stick electrodes in people's heads. Sometimes you have these electrical sensing devices you can put on your head. This particular result is interesting. This is giving the AI-based system the ability to look at an EEG trace over many, many, many electrodes and to reconstruct the image. So in this diagram here, let me move this out of the way. No matter what I do, this is always going to be in the wrong place. So the original image is at the top here, and the reconstructed image is below. That's astounding. I'm frankly amazed that they could do that. So I suspect there's something a little magical going on here. I mean, the colors are the same. Where did the color information come from? From the electrodes? No, I don't think so. So the question is, how do they actually, the reason I'm telling you this is this looks very sexy and wonderful and groundbreaking, all that stuff. I think there's some magic going on here that they're not talking about. I'm suspicious of this result, right? I would have expected the image reconstructed to be black and white. I mean, look at the colors in the reconstructed image on the bottom. So there's something interesting going on here. We'll have to figure that one out. So if you have an interest in electrophysiology or BCI and stuff, go read the paper and tell me what you think next week, okay? Here's another brain-computer interface story from this past week. This one is a brain implant that's a little different. Usually, brain implants are, you take off part of the skull and you put these electrodes in the back of the brain. And the problem is brains hate metal, right? Electrodes are, by definition, metal. So you got this problem. Anyway, and so they tend to be very, very small. You put a small section on there, and it's kind of a pain. This is slightly different. So what they did for this brain-computer interface is they basically took a little cylinder of electrodes and threaded it up into the jugular vein, this one right here, up into the area right next to the motor cortex, so which is roughly here. So there's a little tube in this guy's head in there, imagine that, in his head next to motor cortex, and they use that to decrypt the signals. No color information involved, right? So what they do is now they trained it to basically allow him to run Alexa. Well, kind of a cool application. And so I'm impressed by this. This is clever work because I would not have thought about the idea of threading electrodes up through your jugular vein. I mean, that's really invasive. So there's got to be another story behind why they did that, but whatever. The other thing, though, I believe this result, actually, that they can do this, because there's not that many bits of information per second that you need. However, If you look at that picture, he's sitting at the table, running his Alexa device in front of him. Awesome. That's a setup. He sits in a wheelchair 99.9% of the time, okay? And so when you look at that picture, you think, oh, how wonderful. He can use it at his home, in his kitchen, it's just fantastic. No, he's usually in a wheelchair with his arms on the thing. He's totally paralyzed, right? So when you read stories like this, you have to be skeptical. You have to be skeptical about these things. So don't let the pictures fool you. I totally believe the results here, as opposed to the other one where I'm deeply skeptical about that. But this is the kind of thing you have to think about when you're reading AI news of the day. There's an ML model behind this. I believe they worked, but careful about the presentation. Okay, we're going to do a couple minutes of mechanics here. So this is our next assignment. We're going to talk about this our tomorrow's assignment in just a second. Let me click through here and show you. I know a couple of you asked me to make it public, and I did that this morning. So this is thinking about the next assignment, okay? So what it is you get an official reason to go play with an art generator, a Gen AI art generator. This is actually your assignment. And so I want you to, this is due March 5th, so you don't have a lot of time, but it's totally fun. This is the most fun assignment ever. Basically, I want you to do two things. First, create a party invitation. Just imagine you're having a party, your apartment or dorm or whatever. And what would it take for you to get Mid-Journey or something to create that invitation for you? Okay? Be sure you have time and date and place and all that stuff on it, just the way you think about it. Okay? The second part is then do a very similar kind of task, except a different party using traditional tools. Use Google image search, whatever, okay? Very straightforward. Then the real work, so basically this is going to be a 3-page assignment. 1 image with the invitation to the party. 2, the invitation to the Apollo party. 3, I want you to think about what just happened. How well did it work? How well did it not work? What problems did you have? I will tell you, this is the 6th time I've given this assignment. So this is over 5 years, this assignment has changed a lot. You have it better than any previous class. The very first time I gave this assignment, nobody was able to do it. It was that hard. It's crazy hard. Okay? You're going to be able to do it, but I want you to think about the issues you run across. Okay? So that's the assignment. So close that. And I want to reflect for a minute about the answers to yesterday's question at the end of class. So when the answers are interesting, I'll do this from time to time. Here are some of what you said, and I'm not going to. These are all anonymized, so don't worry about it. You're not outing anybody. When I asked the question, what do you think should not be done by an AI system? Some of the answers were legal judgments. This is interesting. I would say 20% of you said this. Legal judgments. It sounds like a plausible thing to do, but we're going to be talking about a couple of cases where we use AI systems to do exactly that. And the interesting result about that is if you study the behavior of judges, right before lunch they give the harshest sentences. Right after lunch they give lenient sentences. Do you want that? Can you, as a prisoner, pick the time to go see the judge? No, you cannot. So we're going to talk about that. So that's an interesting topic. Grading class assignments. All of our assignments will be hand graded lovingly by humans. Interesting story, though. I was talking to the chief scientist at Microsoft, who's a friend of mine, and she was saying, look, Dan, I know you've got this class. Are you using AI to do your class? And I said, well, yeah, but she said, no. Are you letting AI grade your assignments? I said, no, I don't want that. She said, you're crazy. You should be using AI to grade every assignment. So, but I won't learn what the students are thinking. That doesn't matter, Dan. It will give in-depth, focused content analysis and so on, so on. Like, so we have agreed to differ on this. Your assignments will be graded by humans with blood, sweat, and tears. So I agree with this sentiment. Some people said air traffic control, more generally high-stakes operations like air traffic control. A few people also said self-driving cars. You don't want a self-driving car run by an AI. I said, okay. Air traffic control is really, 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 really complicated, and it's very high stakes. Problems with air traffic control now in the US certainly are that controllers get fatigued, you don't have enough of them, they're overworked, they're stressed, all that. That leads to bad outcomes. So it's unclear to me whether or not an AI could do a better job or not. But I understand your concern, but I think this is inevitable. We're going to end up with AI air traffic control. Self-driving car without override. That was the key phrase several people said. I want to be able to override it. Answer, no, you don't. People are crazy. They're stupid. They do dumb things. And so when we have the self-driving car segment, we'll talk about that in detail. Why you don't want human override for self-driving cars. The statistic to notice is that Waymo cars currently have driven several million kilometers, and they've never had an accident. You can't say that for any human. So that's they've been involved in accidents, but mostly other cars hitting them. There's nothing they could do. So that's an interesting point of view. Psychology and therapy bots. Yes, great idea. You don't get a choice in this, unfortunately. There are many, many companies set up right now and starting to set up that's exactly what they want to do, is offer you counseling, personal counseling. And there's a lot of upside to this, which is, they're always there 24/7. And if you want to talk for 5 hours, it's going to listen to you. No human therapist will do that, right? So it's a trade-off. And we'll talk a little bit later in the ethics section about how ethical this is and the downsides of that, right? Because there are distinct downsides. But that's a good point. And military systems. Multiple people said this. Again, this is the cat is out of the bag on this one. There are already AI systems in place to do target selection, and in some sense, automatic, self-guided missiles are a kind of AI system, right? So I understand the concern. Again, the question is not can we stop it, but how can we mitigate the harm? What can we do? So, for example, should we always require a human to be in the loop? We have a class on just human-in-the-loop control for AI systems. Let me tell you, it's really hard. It's not as simple as you think. You don't just want somebody sitting there saying, yeah, shoot that guy, oh, don't shoot that one, right? That's a hospital. So it's complicated, right? Yes?
I wonder whether that question is a false dichotomy question in the terms of like several answers that you provided, that you showed here. Mm-hmm. I could imagine that maybe AI will be part of this process, mm-hmm. or mm-hmm. for example, in the psychotherapy answer, mm-hmm. I could imagine that like instead of having the psychotherapist be an AI, the first step, the screening step, could be an AI that mm-hmm. hand over to the person, like real person, yeah. psychotherapist. In the self-driving car, right. The context, like if all of the cars are self-driving, maybe it is okay to have AI to like entirely control mm-hmm. self-driving cars. So right. It depends on the context, the role of AI, and whether it is you alone or you and like everyone in the same context that right. shift to the AI. So I wonder whether this question is a false dichotomy.
I don't think it's a false dichotomy. I think all of the above is true. You are going to get, for example, screener bots that do that. Or, for example, there's a bunch of bots being developed for legal support that you can call the bot and get answers about your case. It's not taking over your case, right? So I think we will definitely have sort of mixed adoption rates, but I think it's inevitable. At some point, we're going to have a sliding transition towards full autonomy, right? So, good point, though. Thank you. I wanted to give you kind of a little bit of the plot of the course at this point. You can see the whole outline online on the website. But here we are. This is week 2, lesson B, talking about mental models part 3, I guess. So this is the mental model part. Now, I have to admit, I love the cognitive science part of this, right? I'm deeply interested in how people think about AI systems. And it's worth noting, most of AI people don't care. We care. We're user experience people. We're HCI people. That's why I'm focusing so much on this. Next week, we're going to start our first ethics discussion, fairness, accountability, and so on. We'll go to prototyping, design, and so on, right? That week 4, part B, we'll have an external speaker from California, so she's going to be up at midnight, dialing in to teach the class here. She's a very good friend of mine. That's the only reason she's up at midnight. But she's an expert on using AI tools to help do UX design and research. So this is what she teaches at Santa Clara University, so it'll be really great. Okay, that's sort of the outline where we're headed. For today, however, we're going to talk about how people think about AI systems. So in particular, what we're going to do is start up with a couple quick labs. So make sure you've got a laptop. You can do this on a phone, but it's really hard. Laptop's better. So bring a laptop or find a friend who has a laptop. Okay? And what we're going to do is that, and then we'll talk about mental models, examples, and talk about affordances. So here's the first lab. Now, I don't have a QR code. Sorry about that. This part, I want you to do that on your laptop. Go here, quickdrawwithgoogle.com. Okay? And what I want you to do here, I do have it, sorry. Quickdrawwithgoogle.com, better on your laptop. And what you'll do, that's part 2. Okay, let's do that. What you're going to do is explore this a little bit. You can doodle something and see how well it recognizes. So it's a little bit like, remember the very first module we did where you trained a classifier? They built a really big classifier for you. So I want you to try it and see how well it works. And so I'm going to come over here. Oops. There we go. So it should look like this. You click Let's Draw, and go ahead and in this case, draw a motorcycle. And I know you've probably got little drawing pads and stuff. Okay, so.
I see circle, or glasses, or sunglasses, or blueberry. I see bracelet, or necklace, or drum, or binoculars. I see hockey puck. Oh, I know, it's motorcycle.
I did it! Go ahead and explore and turn up your audio. I know it'll be a little bit loud, but you want to have that interaction because it's basically running its classifiers and trying to figure out what you're drawing. Have people managed to get a couple things recognized? Okay, now you can play with this on your own. I want to talk about what you're doing. In particular, what's your mental model of this thing? So now you should turn off your audio. Okay. How is this working? Does anybody have an idea? This is where you participate. Okay, yes.
This was a quite direct pattern recognition, but it's based on user input.
Yeah.
So I think you can actually click on your results, and it will show you the patterns it matched most closely with the
Right.
other users.
Very good. Yeah, right. So the key trick here, what's going on in QuickDraw, is it's got a big library of patterns, so sketches that people have made. So thousands of people have drawn a motorcycle. Thousands of people have drawn bananas or whatever it is, right? Would anybody else get something other than motorcycle? What else did you get?
Clarinet.
What?
Clarinet. An instrument.
Ah, very good. Yeah, very good. So there's a bunch of, so there are literally thousands of sketches in this training set. And what it's doing is when it comes up with a word, it already knows what thousands of those sketches look like, right? So all it's doing is classifying your sketch into one of those buckets. So I will tell you, there are 20,000 roughly images, and it's classifying in one of those 20,000. You will never see, for example, a request here to sketch a laptop because it's not in the set. So this is an enumerated set. So you cannot go outside of the set. That's the point. It's a little bit like speech recognition systems. Even though it seems like it has an infinite vocabulary, it doesn't have an infinite vocabulary. It has maybe 100,000 words in it, something. Yeah?
How do we know that it doesn't just know the word because it gave us the word?
That's the point. That's exactly the point. It gave you the word because it already has a bunch of pre-stored images with that label attached. So it says 1 through 20,000, choose randomly, boom. Here, draw an orange. Okay? So that's exactly how it's working. So the reason we bring this one up is that the mental model could be, oh, it can recognize anything. It's so smart. No. There are much more than 20,000 objects in the world. Okay? So now let's try the next one. So this is another one, and it's called AutoDraw. Okay? So go ahead and try that. Go to autodraw.com. I guess I should check this. Yeah, it still works. And so now here, you're not prompted or anything, but you can draw something like that. Go ahead and try that. And notice what's happening at the top of the screen, at the top of the UI, right? So it's a slightly different system. Okay, is it working for everybody? Again, what's your mental model of this as you're using it? Thank God it's not talking to you, right? So what I drew here, I was trying to draw a pizza. I don't know if you knew that. But actually, you can see up in the upper part, there's a pizza-like thing here. Or I can click on that and see that's a different kind of pizza. But there's a pizza concept in here, right? So what I find so interesting about this is, again, you might believe it can recognize anything. But again, the magic is it's only trained on 20,000 concepts, or whatever the number is, right? Again, it's not infinite. If I started drawing, for example, a horse, it might recognize a horse. I don't know. And that's the thing about the user model, the mental model that people have. They don't know what's in the set and what's out. So if you draw, for example, a wrench, that's fine. But suppose you draw a pin wrench, which is a very specific kind of wrench. I bet it's not in this set. So it will never recognize it. Okay? So that's, in some sense, the point of these two exercises, is that it, oops. There we go. The point of these two exercises is to illustrate the difference between a naive mental model and you, a more sophisticated audience, your mental model, how this works. Okay. So if we think about the human aspects of this, where would such a thing like this be useful? Any guesses? Recognizing a sketch is intrinsically not a useful thing, right? What would you use it for? Any ideas? Chad.
When you try to search for clip art.
When you're searching for clip art, that's a great one. Another one? Anybody else? Yeah, you've got an idea? What do you think?
I might have thought way too general, because whether it is a simple sketch or something more complex, it's in the end it's pattern magic with images, right?
Right.
And being able to recognize images and match it to a known database or make a
Right.
best guess from a known database can be used very
Right.
broadly.
Right.
Like, for example, in recognizing cancer cells, in tracking wildlife. In
Right. Yeah, we're
categorizing
going to talk about
images, whatever.
exactly right. Okay, and you had a thought too. Oh, for assistance use for handicapped people or so on. Yeah. No. Okay, so let me show you where this shows up in Google Docs. Did you know Google Docs has this? No, you did not. Nobody uses this. It's too hidden in the UI, but I'll show it to you. So Google Docs allows you to insert special characters, and what you can do is draw the character. So you can, for example, draw a character. Remember the thing we just did, the lab we just did? It's the same thing, except it's trained on characters, the whole Unicode character set, right? So here, I don't know how to type lambda, so I just draw lambda. It says, there you go. Oh, and here are some other characters a little bit like it. That's not a Greek character, right? But it looks kind of like a lambda, right? And if you get even more obscure, you could do triple greater than. I don't know the Mac keyboard combination for that. Or for different languages, you can draw characters like that. So the Cherokee character, psi, looks like that, and you can just click and insert it. So that's a really nice application for this product. Now, as was just mentioned, right, it'd be great if you could do a sketch and search over, say, an image database or an artistic database. And so Creative Labs at Google built exactly that. Same idea. You've got this this limited set of images, 50,000, whatever the number is, 50,000. You train your recognizer on it, and you allow people to sketch and retrieve the images. So, oh, this is not, oh, sorry. I thought that was a video. There is a video. If you want to go check it out, go check the URL there. There's a video showing this in use. But it's exactly that. And here's an illustration. The person has drawn the guitar and retrieved this image. Like, that's pretty awesome, right? However, because you know every time I show you something like that, Dan is going to say, however. It's just the way we work. What other issues might come up when you're searching for a guitar? You might have retrieved that image, and you might say, that's pretty good. You might have retrieved that image. That's pretty good. You might have retrieved that image. But now you see where we're going. It's starting to get a little odd. What if you're actually searching for that image? The title of this is Woman Playing Guitar. That's a little hard to see. It's never going to pattern match based on your sketch. It has to match through some other mechanism. How do people think about these things? Again, they tend to believe, incorrectly, that the mental model is all of human art is in the data set, and I can retrieve it. I'm going to sketch the Mona Lisa. Oh, it's a woman, and she's smiling, kind of, and there's trees in the background. You know how many pictures are like that? About a zillion. So the question is, how effective is this as a retrieval mechanism? When you're retrieving over a small set, like just the characters in Unicode, that works pretty well. When you're retrieving over all of human art, good luck. So, as you might expect, there are lots and lots of ways to think about images and image retrieval. And so a friend of mine sent me these elephants, so I took a picture of these wooden elephants. And I put it in my Google Photos and thought, oh, that's great. And if you ask, for example, ChatGPT to give you a description of this, I'm sorry, this is Gemini. It says it shows 4 black elephant figures and blah, blah, blah. And it's actually great. It does a good job, right? Now, remember, this image is in Google Photos. And I've already complained to you about Google Photos. And of course, if I do a retrieval searching for elephants, blah, 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 I do have elephant. Where's my picture? It's clearly elephants. Gemini even knows it, right? Google knows that that's an elephant, but Google Photos doesn't. What happened? What happened is that the left hand doesn't know what the right hand is doing here. So Gemini which can describe this thing, is not connected to Google Photos. And so this is true of every company's AI offerings. They will have different capabilities scattered all over the place. So if you go to the Google AI Studio, which offers all the APIs to all the models, there are 21 different models. Good luck finding the one that does exactly what you need, right? So now we need a meta search for AI models. And of course, every day you probably see in the news, this model from this company has scored better than anybody else on this particular standard test. That's probably true, but I'm getting model fatigue. I don't know about you. It's just kind of crazy. So the different offerings may or may not connect. So what's your mental model of the Google AI offerings? There's everything for everybody somewhere. You just need to find it. So what I find so interesting about this is what I can do is write a little piece of code that asks Gemini to describe this image or to describe that image or that image, and then take the text, which is the description, and pull it out and plop it into the description of the image in Google Photos, right? This is about a 10-minute piece of coding exercise. And then you can basically iterate through all the photos. You'll have now a complete description. If I search for elephants, I will be able to find that picture, right? You are the left-hand and right-hand connector. And part of what is going to be happening in the field as we go forward is people doing exactly that kind of thing. I don't know of anybody else who's done it, but I predict somebody's going to do it soon. And all of a sudden, the ability to retrieve photos by doing text searches is going to get a lot better. Okay? So, how do people think AI systems work? What do they do? How do they think about these things? Okay. It's interesting. Okay, so how do they think about that? So what I'm going to talk about for the next little bit is about Google search, because that's the biggest AI system I know about. Again, most people don't think of it as AI, but it totally is AI. So let's talk about what this means. So I want to walk you through the process of understanding someone's mental model. So how would I talk to you and say, what do you know about Google search? How do I design given the different kinds of mental models that people have? So typically what we do in the UX research group is to discover what people are thinking. We do all kinds of things. We do surveys, we do in-lab studies, we do field studies. And so what I'm going to talk about in particular is looking at interviewing people to understand how they think about what's going on with Google search. So I want to understand, for example, how they think about their search moves, what their intent was, how their goals change over time, how their understanding changes over time. Let me give you the end result here. People's mental models shift slowly. People's mental models shift very slowly, and they're often wrong, right? I was interviewing one person, and she said, you know, you can tell how much the advertiser is paying Google by the choice of font. Blatantly not true. But she was convinced that by looking at the font, she could tell, oh, this advertiser paid a lot of money to Google to get that ad there. Okay, right? I told her that wasn't true. She doesn't believe me. Okay. So I could give you an entire multi-week class just on this one slide alone and all of the stuff it means. In fact, this is what I was teaching at UC San Diego. It was exactly this, how to do this. But what I want to focus on right now is what it means to do a field interview with somebody to understand what they're thinking about your favorite AI system. How do they think it works? So in particular, the reason we do field interviews or field studies is there's all kinds of information you can get by being in the field you cannot get by a lab study or a survey or a logs analysis, which is the other three mechanisms that people use. I mean, they all have their interesting problems, but I will tell you, there's nothing quite the same as being in someone's house, watching them use Google, and having them yell at you. I'm not kidding. I'm not kidding at all. People will yell at you as the representative of Google, say, this doesn't work. Like, okay, tell me more, right? And so these kinds of things happen all the time. So there's a whole bunch of energy, sort of mental, emotional, and psychological energy that never shows up in a survey. But by being in the field and watching people use your thing, you can start to understand that. So I'm going to show you, I have literally hours and hours and hours of field study video. So typically what I would do, I or one of my people, would go out and interview somebody in their place of work, in their home, wherever they use it. So when you bring someone into the lab here, you've already created an artificial setting. You've already created you as the experimenter. You know everything. I know nothing, right? If you go to their house, it's their home, right? It's a different setup. And so you discover also a lot of interesting things that you will never, ever figure out when you bring people in the lab. I mean, don't get me wrong, lab studies are useful, but they're limited. They're limited. It's a very artificial construct. So when you go to someone's house, I've literally had people yell at me. I've had my tripod sitting beside me filming. I'm talking to the person. And the dog runs through the house, tips over the video camera. I have to fix it and catch it. It's a mess. On the other hand, we learned that the dog's health and well-being is a huge focus of the searches that this guy is doing. Like, would never figure that out in a lab, that kind of thing. So let me just show you a little bit of this video. I'm going to skip around through it. This is me talking to different people, asking them, how do you think Google works? I'm going to skip forward just a little bit.
Word comes up, and wherever it's populated in something out there, it gets pulled
This is her workplace.
as part of the information.
So this next one is, I'm talking to this woman. Listen to the response.
Well, I think it lists the results of the search that are most relevant, and then kind of goes down from there.
How do you think it finds those and sorts them?
Notice the pause here. She doesn't have a clue. Right? This is the guy's
Probably
office.
by the, well, certainly the keywords in the title of the page or the first few lines in the page. I think that's, the basics of how it works.
Well, it's got to have, because that exact wording, I mean, I'm thinking that exact wording, that specific topic is in a link somewhere.
It doesn't look for the most popular searches, like the most people that have looked for that word and where they click the most, isn't it? I think that's part of it.
Okay.
So I can go on.
That's
But
always
the
been-
irony about that previous one who just said, I could, it's in the link or something, she used to work at Yahoo, and she didn't know that. And just for the record, I have approval from all these people to show you their videos, so it's all okay. But what's so interesting in talking, and these are kind of representative people, I haven't cherry-picked the videos, is you get this kind of response all the time. People really don't understand it. Prediction, they're not going to understand your AI system either, right? So the question is going to be, what can we do to help make things better? Because people don't have, by and large, functional models of search. They do something and then magic happens. Remember that? Magic happens. So how can we help these people, right? So they type words and things happen. They don't have any causal models, so they have weak predictions about what's possible. People also like to minimize their total cognitive effort. So we have to figure out how to teach them when something shifts, when the new release happens. We give you vast new capabilities. Click here to see what we can do. Like, nobody's going to click there. It's like reading legalese. So we have to figure out better ways, and there are ways to do that. So what's interesting is these folks at University of Washington basically discovered all this stuff is true. They discovered that basically, and this is a fancy chart basically showing that people ask you, Google or Yahoo or whatever, all these different search engines, once or twice a day. So they use it a lot, have no idea how it works. So here are some sample information needs. Now this note this is not the same as what you type into Google. So for example, why are there police, ambulance, fire truck lights next door? What do you think the query is? Fire truck. So there's a lot of context, and so people don't even think about this very much at all. They just assume magic is going to happen. And so they assume that when they type that fire truck query into Google, it's going to know where they are, what time it is, what's going on in police services, and so on. Okay? Best example of this, a guy comes up to me and asks, I have a home page. And when I search for my name, it never shows up. Why? What's your name? John Smith. Let me tell you, there are about 20 million John Smiths in the world. Some of them have thought about SEO for their homepage. And so the 1,000 John Smiths in front of you, you have to do more than just look for your name. So where do you work? Well, I work, XYZ. John Smith, XYZ, boom, #1 result. Okay? So people don't understand. You have to provide a little more context. The interesting thing now, as we shift towards LLM-based search, is providing, it used to be that providing context was bad, now it's good. The more context you can give to an LLM often improves the quality of the result that comes back. So they do this kind of thing kind of once a day, and they ask this question, what's it doing? Remember the last time I said, what's it doing? Aviation surprise, automation surprise, okay? So the classic definition of a mental model is from this paper by Don Norman, Diedrich Gentner, and Stevens. Basically saying it's a set of things that the user believes about a situation, a system, or whatever. So usually the facts, procedures, expectations, and repair methods. So it's all this kind of stuff, which I think of as kind of a welter of knowledge. And a welter is a fancy English word meaning whole bunch of stuff all laid on top of each other. May not be coherent. So this is my sketch of what a welter would be for the mental model that my contractor, John, has of the remodeling project in my house. So he thinks about the spreadsheet of costs, he thinks about the blueprints, he thinks about all the concepts involved. It's not a neat little box you can draw a line around. So these things change over time, right? As you learn more and as things change. And what's so interesting is that this is by Ephthymidas and Dave Hendry, where they basically ask these questions about different concepts people might have about search engines. Everybody knows what a query is, but nobody knows what a content linkage is. Almost nobody knows that. Which is really weird when you think about it, because you would think, for example, that ranked results, right? The fact that the results come in a priority ordering, they come from best to worst. What is that? 15% of people know that? That shocked me the first time I did a field interview, and we were talking, and I said, why is that one in the first position? I said, well, the subject said, I have no idea. Why? Is it better or worse than the other one? And they said, no, the results are in random order. Really? The #1 message of Google didn't get through. And this is not a failure of marketing, it's a failure to communicate a functional mental model. So, so this is the number of times people have correct mental models about, say, the content, the queries, rank order, or so on. And it's just, people don't understand these things. In particular, this one always irked me. 10% of people know that you can search within the results. So if you do a query, get 1 million results. How do you search within those results? You append something to the end of the query, and you can search within those results. It'll be the same, right? It'll be a subset. Nobody understands that. I know you do, but you're clever people. So the mental model is an interesting thing because when people have non-functional mental models, they are what I call this kind of cargo cult. You ever heard that phrase, cargo cult? Okay, a cargo cult, the history of it is that after World War II, in New Guinea and places in the South Pacific, there was this flowering of religious belief. And what they were doing here is they would believe that if they made little models of airplanes or models of white men or built radio towers, the planes would come and bring the cargo. Clearly not true, right? Didn't stop the whole religion from starting up. So a cargo cult is people who have a belief system, a mental model, that has no bearing on reality, right? But they think it will cause something good to happen. And you see people doing this all the time. Let me ask you, have you ever copy-pasted a piece of code without knowing how it worked? Yeah, I know you all have. I have, right? Especially when somebody sends me a sed or an awk expression or, God forbid, a Perl expression, and they say, just run this over your data set and you'll be fine. I have no idea how it works. Okay, that's cargo cult programming. Cargo cults, you see this all the time when you're looking at people's mental models. And so, here's an interview I did with a young man. Perfect young user of Google. And I said, so tell me about how Google works for you. He says, I don't know how it works. I just type words and answers come back to me about anything at all. I said, well, give me an example. What's the most outrageous thing you can think of? And he asked a question about the academic caps. It's like, yeah, look at that, it worked. The answer was completely incorrect, but he didn't care. It worked for his example, and that's what he cared about. So he is a cargo cultist about Google search. So I guess what I would like to do is take a quick 5-minute break here and come back, let's say at 8 till, if we can be that precise. What the heck? 5 till. We'll make it 5 till. We'll give you an extra couple of minutes because I need to get some water. And we'll pop back to talking about the mental models of search. What's in the welter, okay? Go. Okay, let's get started again. And I'm going to reveal my ignorance about something. I'm going to teach you about my mental model. So this is Google Slides. And what I'd like to do is to see the presenter view, right? It's a secondary window. It should be down here. But I just learned that if I switch the view from this is a Chrome window, full screen, and if I open it up with the presenter view shows up down here, and I assumed that was a Chrome window. But when I go back to here and I open the YouTube video, the presenter view disappeared. I don't know where it is. I honestly have no idea where it is. I just checked around, I checked all this stuff, don't know. And on the other hand, I've got floating palettes here, so I can draw on that screen. Where's the presenter view video? Where's the presenter view slide window? No idea. So I'm going to have to reveal that I need to exit this, exit that with an escape, and then come up here. Come on. Exit full screen. Okay, so now I'm just in regular window, and I want to say, no. I'm trying to exit slide view mode. What is going on here? Oh, I'm in draw mode. How did I get in draw mode? How do I get out of draw mode, more importantly? Exit draw. There's a button you can't see here that says exit draw. Only when you roll over it. This is not supporting my mental model, right? It should have little text that says exit draw. I don't know how I got in draw mode to begin with. Well, whatever. Okay, so here we are. And now I want to say, that's great. This is going to my next slides, but I don't know how to. There we go. And that I just hit escape. So now I say presenter view, and there's the presenter window. Doesn't it look like a Chrome window to you? I honestly have no idea what that is. So I'm going to move it down here so I can continue with the lecture. But this is all very mysterious stuff. Now I switch back over here to full screen, and we're back. Good. So mental models are really important because I did not know how to recover from that, because it's a new kind of window. I don't even know what it is. I'll look this up later. But this is not an AI system. This is simpler than an AI system. So you see the problem. How do we generalize? How do we learn what people can do and how they accommodate failures? So one aspect of this is what's inside of Google. This is the same version of the question we asked, what was inside of the quick draw data set? Do you know? You know what's not in it? No, you don't. You have to explore around for a while. Same thing here. Google is massive. It's a computer the size of a planet, right? What's in it, what's out of it, it's impossible to describe. Another version of this is how do you use it? So the mental model might cover things like how can I actually use all this thing, including questions like how do I express my need and so on. So in our interview process, we think about all these different kinds of questions, try to answer them. So we did an analysis of basically what people need to know, and after thousands of interviews, we basically came up with a 6-bucket categorization of what the mental model is for Google search. And the first part is that people know pure engine technique. They know how to use double quote, how to use and, or, all that stuff, right? Quick query for you. How many of you know about Google Scholar? Okay? Okay, the rest of you who didn't raise your hand, type scholar.google.com and I will change your world. I've lectured at multiple universities, including ones that you know. And I've given talks to the faculty, and there are people in the faculties of computer science departments who do not know about Google Scholar. Yeah. So my point is not that they're dumb. The point is that there's information out there, but it's not evenly distributed. So working in groups, collaborating with partners, talking like we do here, has the ancillary benefit that you learn stuff like this, right? Another example, it's not in this course, but I can tell you anyway. Control F, Command F, you know about how that works, right? Does anybody not know about Control F? Okay, it's okay if you don't. The reason I'm asking is you assume everybody knows that, right? I was doing one of these interviews, like I showed, the field interviews, and I had given, I was watching a bus driver, and this is in Los Angeles, and she was working to try to find a particular piece of a particular document from the Department of Motor Vehicles. And it's a very long document. It's probably 200 web screenfuls. And she's scrolling through this thing line at a time. I'm thinking, oh my gosh, I'm going to die here. And you know, this is just one of those experiences you have when you're doing field studies. What's she doing? I'm thinking, what's she doing? So I said, so what are you doing? And she said, I'm searching for it. What's wrong with you? I'm searching for it. And she's going line by line. And I'm thinking, this is 200 pages long. We'll be here for hours. I said, do you know any other way to find the text? And she snipped at me and said, no. Smart guy, what would you do? And I said, Control F. And she said, what's that? Okay. So I flew home that evening. I said to my wife, you know, I've met somebody today who does not know about Control F. You can predict what the next line is. My wife said, what's Control F? I thought, oh, that's really interesting. That's really interesting. So I explained it to her, and she said, you know, I bet most of my friends have no idea what you're talking about. I said, well, let's do a little study, a little survey. So we did a little survey, and it turns out a lot of people have no idea what Control F is. So this turned into a whole big sub-project for me. I ended up sending out surveys, and I ended up with a data set of like 20,000 people in the US who use the internet, know about Google and so on and so on and so on, 90% of them do not know what Control F is. 90%. I know, it's unbelievable. So I went to the big search meeting at Google with all the engineers, and I stood up and I said this, 90% of people have no idea what Control F is. And they said, no. I said, go home tonight, ask your wife. And a lot of them came back that next day and said, oh my God, I can't believe this. And it's true, it's just true. And so the really surprising thing for me, like Google Scholar, you should know about Google Scholar. You should also know about Control F. So ultimately what ended up happening is when you now do a long query in Google and you find there's a match for exact text inside the page, it jumps to that point in the page because we know people don't know how to do Control F. So that feature got shipped as a result of that field interview and the discovery that people don't know Control F. It changed the way Google worked, right? So these field interviews actually have consequences in a positive way. So we know, for example, that people who do that jump to the Control F text actually get to what their answer is much faster. And we've measured this in other ways. I've written a couple of papers on this. Knowing that one little thing accelerates your finding behavior, your search behavior by 20%. People would kill for a 1% improvement. They would murder their mother. So we gave them 20% by just doing this one very simple thing. Anyway, point is, this is one part of the mental model you need in order to use Google. Another part would be information mapping. Now, this is when the knowledge is things like, when you have different information resources. Quick question, everybody knows what a reverse dictionary is? Oh, okay. You? It's okay, a reverse dictionary. Okay, let me change your mind again. A reverse dictionary allows you to look for the definition and it will tell you what the word is. Like a thesaurus, except easier. There are multiple reverse dictionaries online. So when you're stuck trying to figure out what that word in English is for a really good day with light breezes on an ocean, I have no idea what that word is. You can look it up in a reverse dictionary. Okay, that's an example of information mapping. So you need to know these resources in order to be able to organize your search effectively. So there's also domain knowledge, because we found that people who are doing searches in a domain that they don't actually understand are terrible. Biggest example is medical stuff. I was interviewing one young man who explained to me that he gets patches of white on his cheeks in the summertime. I don't know if anybody has this. You get little white patches on your cheeks. So he does the search. And the very first result is the perfect result. It's an article from the American Medical Association about hypopigmentation. And he skips over it because he didn't recognize the word. He didn't have enough domain knowledge to recognize when he'd found the result. And this is true for any domains. Medical is just the most obvious. And knowing some search strategy is sort of the fourth big area of knowledge. So part of the mental model is, when do you quit? When do you know how to start, when to reframe your query, and so on. The fifth area is assessment. How do you know if this result you've got is believable or not? Where do you learn that? And the sixth one is having site-specific knowledge, like knowing that the layout of the New York Times website is different than the layout of, say, the BBC's website, or name your favorite newspaper, right? Knowing how those things are organized. So there are we identified these 6 different areas of a mental model. Notice that this is not prescriptive, it's just descriptive. So we might find somebody who's brilliant at site-specific knowledge. For example, we found people who are really savants, experts at sports sites. So FIFA, they know that site inside out, right? Or their favorite sports team website, inside out. But they know very little about search strategy. Or they know very little about pure engine technique. So these patterns you see in search behaviors reveal the underlying mental models. So that's what we're looking for. where when we identified these 6 different domain areas, what we said was that, look, when you see people doing searches like this for a constellation versus planets invisible in the night sky, or Red Hat versus Red Hat Society, or sawdust near Stanford, right? So we see these things. There's a lot of hidden knowledge in each of these queries. For example, sawdust near Stanford finds a builder's site where you can go and build, things out of wood. It's like a place it's a communal wood shop, okay? This just is a place where you can buy sawdust, very different thing, right? So how much you know and gets encoded in the query, so how you use the system. And those are the different kinds of knowledge we see expressed. We also know that search is often this multi-step process. So, for example, navigating to a good site, orienteering we call it, is often a way to get to something as a way rather than using Google. You use Google to get to a location. And then you can ask for specific kinds of questions like actor most Oscars versus Oscars. Do you want to drill down from these results or just go straight to the result itself? That query on the left, if I said to you, which actor or actress has won the most Oscars? I used this for a long time as an evaluation method because I would watch people search and they would often get the wrong actor because they'd be led down an incorrect path. It's an interesting thing to think about. And then you can often this orienteering thing where you're searching by following a path or scoping a search like just jumping to a site like, say, YouTube or Apple or Amazon in order to fulfill your search there, okay? So that's another kind of skill. So there's all these skills that people have. Or when you're stuck, what does your mental model tell you to do, okay? What do you do in that case? As an example, what do you do when there's something you want to find out about, but you don't know what to call it? What do you do? Ideas? Do what? Asking Gemini. But let me show you an example, right? So here's a sailing ship, and I want to figure out what's that, right? How do you ask that question? I will tell you, I've given this question to a lot of people. Nobody can describe it. It's a long ribbon at the top of a mast, blah, 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 blah. What would you do?
I would ask, give me all the parts of the sea.
Yeah, that's what I was looking for, yeah. So description, this is exactly my point. Describing things that you don't even know what they're called is difficult. So for example, I might have a brown dot on the back of my hand. I might say, Google brown dot, right? But it matters whether or not it has a little white edge on it. And so there's a lot of features you may not even perceive that you need to know to ask a question like that. But asking for a description of the thing is actually a good idea. So in this case, I said, show me a picture of the ship with all the parts labeled. And this is all the labels. So you can actually go look up what that thing is. It's called the topmost studding sail. There's no way you would know that, right? So that's a strategy trick, right? So you know the strategy, obviously, right? And in using computers, right, stuff like this happens all the time. So here's a fragment of a Word document. And what's that thing? I don't know. There's no rollover for it. So when you roll over it, there's no pop-up little help tooltip. So you never can figure that one out. Or how about this? What are those things called? They're called tabs. They don't look like tabs. They don't represent tabs in any way, but they're internally called tabs. Or this. So here are tabs, right? And here are tabs. So tab is kind of this expressive idea, right? So we're stuck in this world where we've got concepts or things we see, we don't know how to express them to the search engine. This is going to be true for AI systems as well. This is, in some sense, what prompt engineering is all about. How can you say the right words to get the AI system to do the right thing? So our Gen AI art project for the next assignment, how can you say the magic words to get it to draw you the picture you want? It's literally like magic. You make an incantation and hope the right thing happens. Okay? That's sort of the state of the art right now. But at this point, what's this versus this versus this versus this? So you see the same thing in multiple UIs. Is it a drop-down menu? What would you call it? So I don't know about you. The doorways in this building drive me crazy. Do I push or pull? And sometimes they're labeled, sometimes they're not. And I always do the wrong thing, right? So
there's this door on the 10th floor of the Vox Media office that I hate so much. God damn it.
I'm just gonna let it run. It's so perfect.
You ever get this door wrong?
Pretty regularly.
Have you seen people misuse it?
All the time, every day. Constantly. I hate this door.
Me too, Kelsey. But here's the thing. As soon as you start looking for confusing doors, they are everywhere.
It's push.
Why? I feel like Roman Mars would know about this.
This is 99% Invisible. And those doors you hate are called Norman doors.
What's a Norman door?
Don Norman wrote the essential book about design. He is the Norman of the Norman door.
All right, and where is this guy?
You must go to San Diego.
Okay.
Hi, Joe.
Hey.
I'm Don Norman. It's hard to describe what I am.
Well, he's been a professor of psychology, professor of cognitive science, professor of computer science, a vice president of advanced technology at Apple. But for our purposes.
I was spending a year in England, and I got so frustrated with my inability to use the light switches and the water taps and the doors even, that I wrote this book.
So there's a couple of reasons I want to put that out. So you know Don, right? So I worked for Don for many years at Apple, and he's a friend of mine. And he coined this phrase, well, after that book came out, The Design of Everyday Things. Norman door came to be a door which the affordance of which is not obvious. The affordance is the thing that you look at and you understand you can do with it. So you look at an AI system, and what's the affordance of the AI system? It's expressed through the user interface, right? So this door, it's a little ambiguous. It's got a handle, but do you push or pull? Now, if you know about architecture and designs of classrooms, you know it has to go out, because if in an emergency, these people need to get out, it's not going to come in because it will block people, right? But that's a lot of background source material knowledge. If you're just in the hallway, it's unclear which way it goes, right? And it always frustrates me because I'm always pushing when I should be pulling and so on. Anyway, Don Norman came up with this, and the key idea here is that a good UI expresses the affordance of use. That term affordance is going to come up again. So we're going to come back to that concept. But think about, what can you do with each of these? Can you ask about the weather? Can you ask stock prices? Can you ask it to guide you through a recipe? So remember, what does it mean to speak an arbitrary natural language to these systems? Can you, for example, walk in and might use a Google Home device, say, turn on the lights? Or could I say, order on Amazon, a case of creamed corn, right? Or could a friend of mine walk in my house and, to spoof me one day, say, okay, Amazon, order 1,000 cases of corn, and it would be delivered to my house and I'd be stuck with the bill, right? So what can you do? And in spoken user interfaces, it's really hard to know. It's very difficult to know about its capabilities. So we have Alexa, we've got various UIs that you can speak to, we've got Siri things, there's a bunch of them, right? So what we're trying to do here is set expectations. That is, tell you what the affordances are. And we've seen a version of this before. which of these UIs do you prefer, right? Try simple spoken commands versus your version. Ask me anything about how to improve your runs. You know the answer to this, right? It's the one on the left. We like this one because it gives some examples. It's very straightforward. It doesn't overset your expectations. It's describing the affordances of the device. So it may be obvious to you, but we've talked about this one before too, but I'm bringing it up for a slightly different reason. So suppose you've got a UI like this, all right? Again, it's the Google Slides. I want to animate some text and presentation. How do you find the UI element, right? Anybody? So we talked about this before. You have to search for motion. Now I'm bringing it up here because if you look at, right, if I say help animate, it says, well, maybe transition. It's not the same thing. That's transition from slide to slide. It's not moving an object on the screen, right? So that's kind of not right. And I don't even know why it gave me that as an option. So it's a little weird, right? So what do I do? As a user, when I finally get the animation option to show up, it shows up over here. We already talked about it sliding stuff around. Now, when you type help, when you go to the help box and say animate, it doesn't help much. You have to know to search for motion. Now, the thing that kills me about this is here we search for motion and we get the motion option, which when you show up, it says animation. Like, okay? The obvious inference you should make here is, I thought I was searching the text of the help menus. I'm not. I'm searching over some other list, which is not the same as this list. This is a bug, right? This is clearly just a design failure. But it's giving you the wrong affordance. It's the Norman door of user interfaces. It's giving you the wrong hint about what you can do. Because add animation, wait, I searched for animation. What's going on here? So the point is, that's funny, where is that? Here we go. The question here for us to think about in terms of the user model is, what is the capability of Google Slide Search? How does search work in Google Slides? It's not Google Search, obviously. How does search work in any help system for any application, including your AI system that you're going to build next week? When you ask for help, you're in a particular relationship with the system. What can you do? I naively thought that when I searched for the word animation, it would find all instances of animations in all of the menus. It's clearly not doing that. So I would argue it's a terrible failure. It also doesn't even do synonyms. When you use different search systems, so for example, you go to your favorite site, say the University of Zurich website, when you type something and search for it, does it do spell correction?
It uses Google search.
Yeah, I helped to create that system. Yeah, that's site-specific search. So in that case, how did you know that, by the way, that it uses Google search?
When we search on the university website, it just shows the result of site-specific search in Google search, and it just...
And there's a little banner that says search by Google or something like that, yeah. So I will tell you what it's actually doing. It takes your query, prepends site : uzh.ch, and then postpends whatever your query was. So it's just searching with, that's actually not a bad idea, partly because you get synonyms automatically. You get synonyms for free. But if you use somebody else's website that does not use Google search, site search like that, you won't get synonyms, you won't get spell correction. So, for example, in the US, the Smithsonian, which is a well-known museum organization, if you misspell something just slightly, sorry, it's not going to find it. There's no spell correction for that. So you should not be inferring the capabilities of these systems. You have to discover it somehow. So the point is, this is not the way search works inside of Google Slides. So why am I doing this repeatedly, going on and on about mental models? Because Here's a complicated device, right? This is the valve stem on my mountain bike at home. And what's interesting about it is this was patented in 1897. And it's not a particularly complicated device, but you have to know that for this, if you want to let some air out, what do? Anybody? Yeah, that's what everybody says. You go, that's not the way it works. You actually have to unscrew it, right? This is called a Presta valve, and you have to go blub, 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 unscrew it, then you can press it down. And so if you don't know that tricky step at the beginning, you're stuck. You're never going to get the air out. Or you're never going to be able to get air in because it's totally blocked. So that's a kind of affordance in a very simple device. We are talking about immensely more complicated devices, the AI systems we're curious about. So we're going to talk about prompt engineering in a future class. But I want to talk for a minute about these kind of affordances that we see in modern AI systems. So one thing you can do here, this is a demo where you can make a sketch and have the AI system generate various versions of different quality renderings on that. And this is now pretty common in Gen AI systems. So one of the things you might explore, hint, hint, one thing you might explore is giving a sketch to some of these Gen AI systems and seeing what it can do with it to amplify it and give you more precisely what you want. But this is an affordance, and it's very clever because you can then say, well, give me 4 different versions of my sketch, right? You can then say things like, do photorealism, blah, 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 blah. But behind the scenes, there are also hidden parameters. So for example, we can do the height and width and all that stuff, different numbers of images. But then you can tinker with things like this. This is the diffusion sampling method. We'll talk about diffusion methods in a future class, but you can switch algorithms, right? But this is all hidden. This is, again, the Norman door of AI. You don't know where this stuff is. I could show it to you, but you have to have a human show it to you. And so I'm going to show you this short video. This is from a couple years ago. It's called the Google Duplex system. And it's actually a very cool natural language generation, speech synthesis and response system. And I'm going to show it to you. Pay attention to how you think it works and what your reaction would be if it called you. Because it's a system that will call you and ask for information. Okay, so let's play this.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second.
The AI generated that.
Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
Okay, so stop. Stop, I say.
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When?
So it's correction, huh?
Next Wednesday at 6 p.m.
Oh, actually we reserve for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
So this is brilliant in many ways. Here's the backstory. So this is a system called Duplex, and it was built in 2007 and announced in 2008. And not 2008, 18, whatever it was. And there's a couple of things really interesting about this. There are a lot of what are called paralinguistic interjections when you say or whatever. So the speech generation system has that solely to make you think it's a real human. You know what I mean? That's an example. So the speech generation system is very high quality, has this paralinguistic utterances that make you believe it's a human being. Does a good job. And what it's doing behind the scenes is when you invoke a duplex instance, you say, here's a template. Here's about a bunch of things I need to find out from this conversation. The time of the appointment, where it's going to be, how many people. It's just a table with the descriptors of the variables to be filled in, and then the values on the right. And so the conversation starts by saying, I need to figure out when to have a reservation for a haircutting appointment and what time. Then you go back and forth. And so it doesn't matter what order you do these things in. It's not a strictly grammar-based process. It just keeps going back until it fills in all the slots, and it's done. Good. But what it's doing is it's consciously imitating a human conversation. That's awesome. Except it really pissed people off. So the reason Google built this is that, there's a whole bunch of information in Google Maps. You ever wondered about that? How does Google Maps know that Raclette Stew or this place downtown in the Altstadt, how does it know it opens at 6 p.m.? The answer is Duplex called them, had a conversation with somebody there, updated the data set for that restaurant. That's how it works. So this is a deeply valuable thing for Google. They make roughly 1 million phone calls a day worldwide with this to figure out when the opening and closing times of restaurants are. Okay? Now you know. But what's so interesting to me about this is when people found out it was a bot doing that, they went, wait a second, I don't like this. And so Google changed its practice to say at the very beginning, the current practice now is to say, hi, I'm the Google bot and I'm calling about the hours for your restaurant. The rest of it is the same. Okay? So with that little disclaimer at the very front, the affordance, the interaction model becomes clear. I'm talking to a bot. Okay? And it was solely in reaction, public reaction, because Google initially thought, oh, we can just pass this off as a human, it'll be fine. Well, it worked until it got leaked out. It was a bot. Here's a prediction. As this becomes increasingly common, the culture is going to change. And that preface, the disclaimer at the very beginning, will be something that will not be required anymore. Right? But we're in transition times right now. So we still have this disclaimer in front of this. At any rate, it works out really, really well, but you see how it discloses the affordance. It's very straightforward. You answer a question, and even though some of those responses were not technically, linguistically correct, they got parsed anyway. And it was able to fill out the table and update the data set. So here's another AI idiom you might have seen. So take a photograph, and you can erase things. Has anybody done this? You can do it on your Android or your iPhone or something. You basically select things and make them go away. So this brings up whole questions about what's an actual photograph anymore. That's another topic. We'll talk about image generation in the future. But you can see it's very, very straightforward. Select the erase option, and then you just select on the image and do it. So here's a picture of my son. And I want to basically remove him from the image. So this is the opposite of erase, right? So what I want to do in this case is select him with my finger, and extract that image. And it kind of does an okay job. There's a bunch of stuff here, artifacts around the outside. But it mostly got it. So I wasn't that accurate in my selection. I kind of went like that, and it figured out his legs and so on. That's sort of clever Photoshop. Right? But the affordance is very straightforward. But what about selecting this guy on the left And I started to do that, and I got text select. What happened here? Well, what happened was that I selected accidentally on his 10. The AI said, oh, you're selecting text. I wasn't selecting text, that was an accident, right? So the interaction model here is to select an object, don't click on the text, click on non-text region. If you want to select text, that's fine, that's a separate operation. So it's trying to give you the text select option versus the object select option. And it wasn't obvious how to do that. Now, I figured that out. There are a lot of people who have no clue what happened. So you can do this now. And here's our last exercise for today. I want you to think about this and talk about this with your neighbor for a few minutes. Imagine that you're a designer of the system. The system is to show relevant images on a particular date. So March 23rd, this set of pictures shows up. That's cool, right? I get my dog, I get my cat, I get my kid, I get a favorite memory from a trip that I took. And I guess the question for you as product designers is what might be some unintended negative consequences of this feature? What do you have to put in place in order to get around those problems? Talk about this for about 3 minutes with your neighbor, okay? And then we'll talk about what this could be. What could go wrong?
But also, like, I found that many of the time I use iPhones to take picture of like notes, receipt, and so on.
Okay, everybody. What could go wrong? Any ideas? How about you guys in the back? What could go wrong?
We discussed that some memories might not be so pleasant, like a pet that is not with us anymore.
Yeah.
And we might not want to see that. And
Good point.
in order to change that, we can have a feature where we name the pet in Google Photos. And then tell Google to remove the pet from the future memories.
Oh, okay, from the memories, not remove the photos, just the memories. Okay. Yeah, yeah, got it. Okay. This also applies to ex-girlfriends and stuff like that. Yeah. Okay. How about you?
I was thinking, what if you take in a situation like you take a selfie, and usually you take a couple selfies in a row, and you have like multiple pictures of the same situations, and you want the AI to show you the pictures where both of you look good, but then instead like it shows you a picture where like both of you
Yeah.
close.
Yeah.
You don't want that.
Yeah.
So that's the issue.
That's a great issue. Anybody from this side? Yeah.
Our conversation dug a little bit deeper in what you meant by, like, we try to differentiate between bugs and unintended negative consequences. And one thing that we came up with is that could it be that if people know that this feature exists and they never get recommendation of this memory,
right,
will they think that, okay, is my life is too boring?
Right. It makes you feel bad because you I hadn't thought of that. That's a good one. That's a new one to me. So these are all great comments. Yeah, deceased pets, ex relationships, all this kind of stuff. Those are the sort of negative side effects of that. That's a great idea. Mark as no longer in your interest set. One thing. Interesting comment about this. Many years ago, I built an AI system that would compose, would basically assemble news articles like a summarization system. Okay? It would do summarizations, and then it would automatically pull out an image from a data set that would go with the article. And that was wonderful up until a time when there was an article about American Airlines announces a new flight to Dallas. The article, very boring article. And it pulls out an image of the data set that's labeled American Airlines, but it's a picture of an American Airlines jet crashing. Oops, sorry. The AI was not smart enough to discriminate between negative images and positive images. Yeah, the other thing is, we were talking about privacy over in the group over there. There's not particularly privacy issues because it's all your data, but when it pops up, it might reveal things to your partner that you wish she didn't know. Right? I will let you figure out what that could mean, but one more comment. Did you have a thought? Yeah.
Yeah, we basically thought of how we can remove these negative events from these memories.
Yeah.
We thought maybe identifying emotions on each image.
Oh, okay. So actually have an AI component that labels it. Yeah.
Emotions
Yeah.
on the images.
Yeah.
So it will be happy events.
Right. Very good. Very good. Okay. So so the UI pattern, we just talked about some ways to modify the stream so it doesn't show you negative things, and only shows the best things, best positive things. So, by the way, there's also an article down here if you're interested in that about how to a study of how these things afford reminiscence or not. There's a bunch of things to think about here. We're going to talk about each of these domains. I'm not going to do about them now, but we're going to talk, for example, about bots, chatbots in more depth in a future class. Here's a couple things. We will revert to this topic again at the very end of class, how to stay on top of this field. For example, what do I do? It turns out I wrote an article last year for Interactions Magazine about that. One thing, if you're interested in these kinds of topics, my blog actually there goes into this in depth every week. So I'll be posting an update later today, about comparing different deep research systems. So I want to end the class with this thought, how much does AI matter in all these cases? Well, it's the underlying technology, so it matters a lot. But more importantly, is how do people understand these things? How do you know how it works? And how much does the interface afford you the ability to figure out what it can do, what it can't do? Okay, try this one. See, the great thing about class is you get multiple QR codes, right? Yeah, there we go. All right, thanks everybody. See you next week.